Welcome back. My name is Brandon, and as you can see behind me, we have an aluminum boat ladder repair to do. Stick around. This is what we're working on today. I don't know a whole lot about it, other than the customer said that it's a boat apparently that he bought, and he thinks that the previous owner ran into something. You can see how the weld is broken over here, and this is super thin material, and it's anodized. You can see how it's pretty bent right here. This is hinged, so what we're gonna have to do is we're gonna try to repair this crack over here. I may straighten this out and weld a plate over this to reinforce it. That way I'm not getting into all the intricacies of this hinge and everything else. But you can see I gotta take some stuff apart. This is plastic. So I'm gonna have to pop a couple of these rivets out and drill those out, but yeah. You can see it's needs some work. And as I said, this material is super thin. It's like 60 thousandths of an inch. So 56, 60. So what I've started to do is I've just been messing with some settings in an inconspicuous area that you won't see. So I've ground the anodizing coating off this and cleaned it with a stainless steel brush, and then just started patting a few beads, and I'll show you some of my settings. And I think this is going to work okay. I am not the official on TIG welding. I don't do it a lot, but I should be able to do a successful repair on this. And I'll tell you everything that I'm using to do it. So now I'll drill out this rivet right here and we'll get this plate off here. All right, flip it over. We might even be able to like clamp this down to the table using some fixturing clamps and just bend this right back into shape, hopefully. I'm going to try to drill these rivets out now so that we can get all the pieces out before I weld this crack up. We'll try to get those rivets out of there. There we go. Got them, all three. The next thing we got to do is start working on alignment, and my intention is just to basically clean this and weld this crack up. But this side is higher than that side because it's been hit right here, so it's stretched the metal upwards. I don't know if you can see that, but that's definitely higher here than over here. So I think what I'm going to do is just prop this side up on some blocks and just hit it a couple times, see if I can stretch that back down, then we can start getting things clamped together. He said he tried getting another one of these ladders and was not successful, wasn't able to find one. I'm new to hit it right down in there to help stretch this. It's just about broken off at the bottom. There, that should do it. That should line up pretty good now. Yep, there it is. It's the right height. I think the next thing to do is get a clamp on this and see if we can start closing this up. And that's it right there, guys. And just so you know, that was a stainless brush that I was using, and so is this. I'm just cleaning it down with some acetone. I don't know if you're able to see it, but we also have a cracked weld right here on that hinge, so we'll try to get that too here in a little bit. And for this repair, I'm using my ArcCaptain TIG 200P, so you can do AC TIG, DC TIG, or stick welding. Then you got 2T, 4T modes. Then you have a pulse, no or yes. I'm on no. Then you have a square wave or triangular wave. I'm on a square wave. Triangular, that'd actually be pretty good for this too, because triangular works pretty decent on thin metal. I'm on 80 amps. This is really easy to set. So you just press this button in. So I'm at 80 amps right now. Press the button in, rotate it over, and my upslope is going to go from 50 amps up to a half a second to get it to my 80 amps. And then it's going to ramp down over the course of a half a second down to 50 amps. And then my post-flow gas is 7 seconds. I've got 30% AC balance. And what else is there? I'm on 120 hertz. And just so you know, this will go all the way up to, what? 200, wow, 250. This machine actually even comes with a piece of tungsten, but I'll show you what I'm using. And for tungsten, I'm using 3 30-seconds laser. This works all the way from razor blades up to 1/4 inch. And for filler wire, all I could find was I had some 45 thousandths wire because I want to use 5.356 on this, because 5.356 wire is better suited on like marine applications where it's going to be experiencing, you know, because this is going to be in the water. This folds down. So it could be in freshwater or saltwater. I don't know how it's going to be used. So I'm going to be using 5.356 filler. And I'm going to show you a little trick on how to make your own if you don't have any. So I just peeled this off my MIG machine right up there. And like I said, that's 45 thousandths 5.356 wire. You're going to clamp one end of it into your vise, and you're going to clamp your other end into your drill. You're going to stand back and you're going to spin this until it breaks, and then you're done. And you'll see what you get. So you just pull a little, just slight tension on it, and then spin it. There it is. Got a piece of TIG wire now. Just like that. Wipe it off with some acetone before you use it, and you're good to go. I don't know if you can see the like little spirals. It kind of wraps it, so it kind of like straightens it. If I spin it a little bit, I don't know if you're able to capture that, but it has kind of a, you can tell it's been spun. It has like a rough feeling to it, so it makes it nice to grab too, so it's not slippery. I really wish I had a pedal, but I don't, so I'm just gonna be doing it by hand. May have to do a little bit, stop, I don't know. We'll see. Without a pedal, you're doing all your settings manually, so I've got to ramp down a little bit slower so I can fill this crater a little bit better, or apply my filler towards the end because you don't want it to crack. That's what will happen if you don't get your crater at the end filled in well. It'll start cracking. The good thing is that this flowed in really nice, so I'm not even concerned that we're not going to be able to repair this. We're definitely going to be able to. The light's not great, but you can see I got a little crater right at the end I got to work on trying to get that filled in, but I'll try to grab it here in a second once I turn things around and manipulate it. But yeah, I think that's going to work really well. It should work pretty good. Actually, while I'm right here, I'm going to fill this crack in as well. I don't want to jinx myself, but this is starting to really come together pretty good right now. I got that end welded in here a little bit, down further. It's actually even better than the other side. And I blended it back into the side here and then started wrapping it around. So now I guess we'll go to the next easier side, which will be this. I'll put it up on end and we'll try to get this all filled in. I want it secured. I don't want it, you know, bouncing around. So, you know, I'm shaky enough as it is without the thing floating out in the middle of nowhere, bouncing around, causing me grief. So there. So here's our next crack. We got to extend it from the top all the way down to the bottom. And then we'll come across here where it's weakened and tie it into this piece as well. Alright, I had to get some more filler wire. We'll restart it. I need to pick up one of those. They look like this type of brush, but they look like a toothbrush, a little one, for doing delicate stuff like this. Get this side cleaned up. I also forgot to mention I'm running about 25 CFH of pure argon, and I'm using a number 6 cup. My guess is if I worked at this factory making these ladders, that my welds would look just as good as these factory welds. But because I don't, and I don't do it a lot, that my welds aren't going to, you know, appear as good as, you know, the ones that somebody that's doing it all the time. I think that came out pretty good. I really tried to force that wire in there. I was doing almost like a lay wire and just kind of like pushing it, because this wire, I actually need a little bit bigger wire. This is like burning through this. I'm already on that second piece that I cut that was about 3.5 feet long. So you can see right at the very end, it actually ended up opening up on me. It just got so much heat in it. But I'll fill that in and then try to weld all the way across. There, we got one side all done. We might as well rivet this back together. I'm going to use 3/16 by 1/8 inch button head rivets. So I need 1, 2, 3. I need 3 of them. Stick one in there. Stick one in there. Okay. Oh, look at that, lined right up. Nice. And there it is. Here's the finished product on this side. So you got an aluminum rivet on aluminum, so you don't have to worry about dissimilar metals, you know, if you use stainless or something like that. And yeah, just kind of looks normal. Doesn't look too messed up. This side's gonna look messed up though, but this side I'm gonna leave on, or I'm gonna try to. I might try to protect it, because if I drill the rivets out, let's see, I don't think I can get them out. No, I can't. So if I drill these rivets out, the other end is gonna end up inside the tube. It's gonna rattle. You're gonna hear it when you're riding in the boat, and I don't have a way of getting it out unless I cut the end of this cap off, and I don't want to make more work for myself. So we're gonna have to do this in a couple operations. We're gonna have to relieve some tension on this by hitting it and then bending it down. We're gonna have to do it a couple different ways. All right, we got it a lot better, but I think what I'm gonna do is put a relief cut on this back to open this up, because this kink right here is creating a pressure point that it's not going to allow me to straighten it. So I got to cut through that pressure point, and then I should be able to straighten it out quite a bit more. It's got to go until that's straight, regardless of what it's doing on that side. It's got to be straight. We knew that was probably going to happen anyways. You've heard the old adage, sometimes things have to get worse before they have to get better. Well, this is one of those times. So you can see how, looking down that's pretty straight. We got to maybe open it up a little bit more at that end, but for the most part, looking down it, both sides are pretty straight right now. All right, I got a gap here. I turn the machine back to 60. I'm going to see if I can fill this gap in. We'll see what happens. Then if we need to plate it, we'll plate it. I don't know. We'll see. All right, I just changed some settings on the machine. I'm at 50 running amps. I've gone to 25 startup amps, and I've changed the ramp down to 25 amps, but instead of over the course of half a second, I increased it to almost a second, just because this is so thin. So this is done. I think that's going to work out really good. Whereas this side was somewhat compromised. I might even, as you can see it's all squiggly, I might even put a patch on the inside just to help plate it, because this is how it sits on the boat. It goes on just like that. So you're really not going to see if I patch on the inside, but you would see it if I patched it on the outside. So I think I'm just going to do it on the inside, that way it's a little less conspicuous, you know. We got our patch on there. That'll help strengthen things up a little bit. There it is, guys. It is done. So that is this side. This is the side that we did first. And then here's the side that we did second. She melted a little bit over here, but I couldn't drill this out, because if I drilled this out, then it would have fallen down inside and it would have been rattling. These are all drain holes. You see how they have like a half shape hole? That's so that if any condensation or moisture gets inside these tubes, that they can drain out. So I wanted to make sure that I did not, you know, weld through those. I wrapped over, it's hard to see a little bit, but I did wrap over into that area just a little bit to help strengthen up those corners. And then here's the second side that we did. I've shaped this a little bit better to try to get some of that burn stuff out of there, you know. Unfortunate, I didn't want that to happen, but it does. Like I said, I couldn't drill the rivets out, or else it'd be inside the tube and they would be making all kinds of noise. But yeah, and then that plate on the inside. Now, it's not the most beautiful work in the world, but you know, it was in pretty rough shape and pretty messed up when I got it. He wants it functional, and this will be that. And as I showed you earlier, this is how it sets on the boat, and then this piece right here, this actually bolts to the boat also, which makes sense on how things broke and ripped. So they backed up into this, which caused this to rip that way. And the same thing over here. I'm guessing they must have hit kind of up higher, because if they hit down here, I don't think it would have sheared it in this place. I'm thinking that it might have made contact up higher into here, which forced this to rip right there. You can see how this is still a little rippled and distorted, but you know, I did the best I could with the bent material that I had. And I'm real happy with how this welder works, so I'm sure I'll be doing many more projects with this. I want to thank you guys for watching. Thank you guys for tuning in. If you're wondering about any of the tools that you see me using, I'll have links down below. New videos every Friday. Until next week, I will see you then. Take care, stay safe, and God bless.